Page 6, number 16. Another situation with two radicals. We need to isolate one of them. I'm going to subtract the simple one from both sides. That'll leave me with this on the left side, square root x minus 40. And on the other side, I'll have 4 take away square root x. I'll square both sides, and that will get rid of the left-hand radical. So that makes it x minus 40. And on the other side, if we multiply this out, let me scribble this up here. 4 minus square root x times itself. What do you get? You get 16. Then you get minus 4 root x and minus 4 root x again, for a total of minus 8 root x in the middle. And then, look, negative times negative is positive. Root x times root x makes plus x. Okay, so that's not too bad. If I take away x from both sides right now to get all, well, let me attempt to isolate the radical, right? So I'll take away 1x from both sides. And I'll also take away 16 from both sides. And then I'll have minus 56 equals minus 8x. Okay? And then if I divide both sides by negative 8, I can do that. 56 divided by 8 is 7. Negative divided by negative is positive. I get that. Well, that's really nice, isn't it? Okay. If I square both sides, I get 49. The square of the square root of x is just x, so I get 49. That looks good. Except, there's always a catch, isn't there? If we try it, it doesn't work. If we put a 49 in there for x, we'd have 49 minus 40, square root, plus square root 49. Does that equal 4? Maybe you can see immediately there's no way that's adding up to a tiny little number like 4. This is plus 7 right here. Square root of 49 is 7. This is the square root of 9 is 3. 3 plus 7 does not equal 3 plus 7. I think that's 10. So, not true. And this was the only value for x we were able to wrangle out of all the legitimate steps we did. There's no other route. So the conclusion here is no solution. Sorry. Okay, next one. Again, let's isolate the more clunky radical. I'll add square root x to both sides. I'll have square root x plus 55 equals 5 plus square root x. And we'll square both sides. Squaring the left side just gets rid of the radical, and we have the radicand x plus 55. On the right side, if we write this out twice, 5 plus root x, 5 plus root x, and multiply this out, we get 25 plus 5 root x plus 5 root x a second time, meaning 10 root x in the middle. And root x times root x, or square root x times square root x, just makes an x. I want to isolate this radical, so let us subtract the 25 and subtract an x from both sides. Subtract an x and subtract 25 from both sides. Nothing wrong with that. Now the x's are gone. 55, take away 25, that's 30. And on the other side, this is 0 now, this is 0. I just have 10 times the square root of x. I can get rid of this multiplier 10, this coefficient 10, by dividing by 10. So I have 3. 3 is the square root of x. Square both sides again to get rid of that second radical. And we get 9 equals x. Does it work? Let's see. If we pop in a 9 for x, a 9 plus 55 is 64. Minus square root 9 is that equal to 5. Yeah, because that's 8. Square root of 64 is 8. That's 3. 8 take away 3 is 5. Yay, it works. Okay, so 9 is the solution for question 17. And that concludes page 6.